Hi and welcome back. In the last video we discussed Fermat's principle of least time and used it to explain why does light travel in a straight line while going through a single medium. Now things will become more interesting when light will go from one medium to another. Light bends in accordance with the Snell's law, which gives us the angle at which the light bends when it goes from one medium to another, depending upon their optical density. Suppose that we have a ray of light incident on this glass slab. After refraction, it will bend slightly towards the normal, like this. The angle at which the light bends can be calculated by using Snell's law. But what if we try to ask the question, why does the light bends? We usually get the same answer, that the speed of the light is different in different media, as the light is slower in an optically denser medium like water, glass, etc. than in air. So when light travels from an optically rarer medium to an optically denser medium, it will slow down. We can agree to that. But why does it bends? The question is still there. We can answer this using different explanations like Huygens principle or Maxwell's equations of electromagnetic theory. But we don't want to go deep into the mathematics and long explanations. We'll keep it short and simple and use our Fermat's principle of least time. Now let us try this thought experiment. Imagine a bright sunny day at the beach. This kid is just like me, who doesn't know how to swim properly, yet he enjoys the water. Suddenly he finds himself in deep waters and at the verge of drowning. Luckily, a lifeguard observes the kid. In the first case, we can imagine the kid is along the straight line as the lifeguard. Now, in order to save the kid, the lifeguard has to rush and reach there in least time. Or we can say he has to choose the path of least time. Now, the lifeguard will run straight towards the kid and he can cover the distance on land very quickly as he is fast on land. As he enters the water, his speed will slow down as he has to swim now. Eventually, he will reach the kid and save the kid in time. If he has taken any other path than this, he would have taken more time. This is what exactly happens when light enters at the interface of two media perpendicularly. Although it slows down after entering an optically denser medium like glass in this case, but it will not bend, as the least time path in this case is a straight line, and light always chooses the path of least time. Now let's go back to the beach, and in this case, the lifeguard and the kid are no longer aligned in a straight line. He is somewhere, let's say here. The scenario is still the same. He has to reach the kid in least time. Suppose he takes this path. He will run straight towards the water and then start swimming in the direction of the kid. The problem here is that he has to cover majority of his distance in water, where his speed is very slow. So it will take a lot of time for him to reach the kid. Now we would think that the path of least time will be the path in which he covers least time in water, like this one. But as you can see, for minimizing the distance in water, we have actually increased the distance on land by a lot. This is still not the path of least time, as our lifeguard has to cover a lot of distance on land. We can also think for a straight line path, as the straight line path would be the minimum distance between 2 points. But still our lifeguard has to cover a lot of distance by swimming in water. So what's the solution? It turns out that if a lifeguard covers a little more distance on the land than the straight line path, he would have to cover less path in water. And this is exactly where we hit our sweet spot, where the time for reaching the kid is least of all the paths available. This is exactly what happens when light falls obliquely on the interface of two media. It will bend slightly to achieve the least time path. If the light is going from optically rarer to optically denser medium, it will bend towards the normal, and the angle at which it bends is accurately given by Snell's law. I hope now you understand the behavior of light, where it bends and where it chooses the path of straight line. It all boils down to one simple principle of least time. Share this video with your friends, and I'll catch you guys in the next video with more amazing concepts. Bye bye.